Students, this course is brought to you to teach analog communications and signals. This course is titled as Introduction to Telecommunications and Signal Processing. After completing the course, you will be able to learn the exact generic meaning of modulation and why we must have it in most telecom systems. Understand most common transmission techniques in analog communication systems, for example, AM, FM, PM, SSD or VSP. Apply analog to digital ADC conversion and digital to analog DAC conversion. Apply the fundamental steps in signal transmission. Use signal processing techniques to recover source data at the receiver. Implement modulation techniques and FIR filters in MATLAB. Analyze communication systems and their components. Basically, for this course, you don't need to fulfill any requirements beforehand. Now, let's get into the description of the course, shall we? This course aims to familiarize students with the building main blocks of telecommunication systems, including both transmitter and receiver sides. Students will learn to use signal processing techniques such as Fourier series analysis, Fourier transforms in data transmission. They will also develop skills to optimize modern communication systems to perform metrics such as reliability in terms of bit error rate, spectral efficiency, in terms of data rate, and power efficiency. This course covers the basics of communication theory, including signal analysis and transmission, amplitude modulation, AM, quadrature, amplitude modulation, QAM, frequency modulation, FM, phase modulation, PM, phase locked loops, sampling, quantization, plus transmission, digital data transmission, and recent digital communication technology. More specifically, the content of the course includes the following: introduction to communication systems and their Internet of Things applications, review of signals and systems, signal types, energy relations, Fourier transform and Hilbert transform transmission of signals through linear systems, filters and bandpass systems for filter design, amplitude modulation and DSB-SC modulation, single side modulation, vestigial side modulation, frequency division multiplexing, phase locked loops, quadrature amplitude modulation, angle modulation, frequency modulation, angle modulation, phase modulation, review of probability and random processes, WSS process, autocorrelation function, power spectral density sampling process, and aliasing, scalar quantization, vector quantization, and encoding. So students, we are very excited to have you with us on this journey and looking forward to seeing you enroll in this unique and interesting course. For exploring related training given by the instructor, you may search for Research Store on Google or Bing.